I do not question for 1 second that how we are doing security in the cloud is orders of magnitude more sophisticated than an enterprise can do. There is no question, right? The ability to bring on the right staff at scale with the tools, all that kind of stuff, fantastic. Unfortunately, the approach is fundamentally not working. If you look at any measure right now in relation to the number of attacks, the success of those particular attacks, this approach is not working. And so why? It's not that the cloud is not secure, it's that we've forgotten about a fundamental part of the attack surface, and that's the endpoint. 95% of all attacks start at the endpoint. And today, we've forgotten about that, and we've forgotten about prevention. So fantastic that we're doing work in the cloud. Awesome. Great technology. Really believe in it. But as an industry, we've really got to step up to protecting against the entire attack surface to really mitigate the attacks.
Right.
The cloud has progressed tremendously in terms of restricting access and control, but there is also a sense of responsibility that falls upon the service providers as well as the users of it to make sure they build in sufficient protection into the kind of services that they're using. You know, identity becomes very critical. Right. You know, privacy of public data becomes important. And I think it's really a combination of this cloud service itself being secure, as well as the applications that are running on it being coded to make it secure.
We are very clearly seeing that large enterprises, for compliance reasons, security reasons, and performance management of their applications reasons, are requiring very granular visibility, particularly in compliance of business critical apps. When you move something into a cloud, you lose the ability to control that visibility. So for on business critical applications that are core to the business, whether it's financial transaction processing or whatever it's your core skills, core transaction traffic and e-tailers, no, they're not ready to put those in the common cloud. Full stop.
We have customers that actually, when they start and they trial our product, they start with those privileged systems folks that have access to everything, right? If there's anyone you want to lock down, it's that team of people. And so that's, we've seen that again and again. And if you look at some of the problems on the security side that we run into, it's the same thing. They have two primary threat vectors that are coming in where these people are getting infected. Whether it's the CEO, whether it's someone way down on the shop floor, they're getting infected through the web and through email. And whether those are hosted in the cloud, whether people run this cloud service, whether they're running traditional old-fashioned services, it's coming in through the web and through email. And so having a prevention system in place, I think Andy touched on it around the fact that prevention has kind of been broken over the last years. We've seen people rotate to, I need to do more about detection and fast response. And I don't want to diminish those efforts, they're helping. But the fundamental problem of people getting compromised and these high value targets that you talked about getting compromised needs to be fixed through improving the prevention capabilities and keeping those accounts and those people safe.
The threat landscape has changed, and I know Andy mentioned, the surface is changing, and most of the security initiatives have been oriented to securing users inside the enterprise.
Right.
And that's fundamentally, it's much more sound. But the reality is, the enterprise, the boundaries have dissolved, right? And they're not just using their PC, they're using their tablet, their mobile phone, they're borrowing a friend's laptop, and they're accessing content in the cloud. And so what's become apparent is security needs to move from an enterprise orientation and even we can't limit it to just specific endpoints. We need to move it to a cloud layer as well. Obviously, you need endpoint type security, but there has to be a cloud layer of security for these connections that are happening outside of the enterprise with devices that aren't under the control and administration of the enterprise. And when you think about smaller and medium-sized businesses, how do they do that, right? They don't have their own cloud to implement security at that layer. So what we're seeing is a tremendous initiative with service providers who are providing connectivity services to offer security at that cloud layer of the network as a service for both large enterprises, but primarily small and medium-sized enterprises that lack the sophistication and the resources to do that on their own.
As some of you alluded to earlier, I think the attack surface is changing. Obviously, as a global telco, we see a lot of it in the connectivity parts of it, but inside of the so-called perimeter, below the WAN layers, we're starting to see the perimeters being dissolved, and we have mobile devices, we have convergence of cloud and mobility. IoT is one thing that stood out very strongly as well. Customers coming to us, augmented autonomous vehicles, that sort of thing. So we are also leveraging on partners. I think half the table here is probably the current partners of BT in our quest to improve security for our customers. And we also built some of our own platforms to look inside our own network, which our customers' data actually travels in, to see what sort of information that we can gather from it using data science and that sort of thing. So definitely we do see a fair bit of security considerations coming to a global service provider like us.
The answer is it's a challenging problem, and when you think about these IoT devices, they're very limited on compute power and memory and those types of things, and they're infinite in variation, right? So right now, it's a growing concern across the enterprise markets, and we're actually working with some of the service providers. If you think about IoT, it's either connecting to your mobile device or your LAN via a wireless connection, or it's connecting via a cellular type connectivity. And so what we're doing is we're working with service providers to provide IoT security, again, at the cloud layer, because those devices are either coming through the broadband connection or the mobile connection.
So I totally agree, and I think that's a valid approach. But just consider this again. Once a piece of IoT hardware has been compromised, the fact that you're doing monitoring up and back,
you're exactly
it's
right.
too late, right? So the challenge in IoT is exactly as you said, Frank. Limited resources, very almost consumer scale construction. So not a lot of memory, not a lot of CPU, not a lot of those environments, and also an environment where quite often they're disconnected, right? So how do you manage an environment and secure an environment that looks like that? And in the end, we have to actually construct technology that allows us to be embedded in those endpoints that actually can mitigate against the attack of malware, right? It's the only way we're going to get there holistically. Once again, we need to protect the platforms that support them, we need to protect the networks, but we also need to actually specifically create protection mechanisms on those devices themselves. And I think that's the big challenge for the industry. Do we really have detection techniques that are effective and efficient, because they have to be incredibly efficient? I mean, can you imagine downloading a 400 megabyte DAT file to an IoT device? That's just not going to happen, right? We have to have a fundamentally different approach. So yeah, I think it's a big challenge for the industry, but one I think we're starting to see some early signs of good adoption.
I actually think that we're a ways away because the definition of IoT is not yet, we haven't comprehended it in its entirety. Case in point being, a television today is an IoT, which is actually running its own version of an operating system, as an example, just purely as an example. And the connectivity to those kinds of devices are through traditional means, which are just discussed earlier. So the point of vulnerability extends right into the operating system in certain cases, which we've not yet fully comprehended. So and this is happening because the traditional owners of either these devices, networks, or operating systems are changing rapidly, right? I mean, Android didn't exist very many years ago, but now it's all over the place. TV operating systems are now in every home. Large organizations like General Electric are now coming up with their own operating systems and stuff. So we've got a ways to go before we get a full handle on it, and I think the vulnerabilities will exist as long as some sort of critical mass is not established and adoption reaches some stage where we can then build that layer on top of it. But we have to keep working towards it.
We've actually been working with some of the folks who are managing power grid and water control systems and things that, if somebody takes over a dam and opens a dam through an IoT controlled system, there's a lot of implications, as you're saying. And so definitely there's been a lot of scrutiny around that.
So all I've got to say, though, is fundamentally, whatever processes and systems we use to set up the current critical infrastructure approaches is not working. I mean, we've just released a report called Dust Storm, which was a low and slow hack of the critical infrastructure in Japan. Right? So that entire infrastructure was compromised. Wow. Right? So while I fundamentally agree we have to test, we have to be conservative, we have to take it step by step here, we do have to fundamentally shift the approach that we're using from a security perspective.
The physical limitation to testing, it's very important, but there is a challenge, and the reason why it's not doable is for two reasons. One is we're not able to conceptualize what kinds of testing needs to be done. So it's a matter of test coverage and figuring out whether it's. The second thing is the physical cost in some instances, like the example that you talked about. In the early days, the analogy I would give is airplane testing. You had to build expensive wind tunnels, which itself was expensive, but the alternative to it was actually physically flying the airplane every single time to test it, and which was just not practical or business feasible.
I'll give you an example of a major financial institution just to put a point on that. We're doing cyber range training services for a major financial institution in Asia. And all we did is we spoofed their website to make it look like it'd been hacked. Okay. It had actually not been hacked. Okay? Just put up a screen to show them that it had been hacked, just to see how the CIO responded. They panicked. They said, we have to shut down our internet banking, we have to shut down our processing systems, we have to shut all been hacked. Hadn't been hacked. That was just a test of the people to see how they responded to it. So that's the last level, not the last level, but certainly it's a level of protection you need to put into your people and your systems and how they're going to deal with it when it happens. And that's the ultimate thing in testing.
Right. So
I've got a really good one, and apologies for taking it so much of the airtime. I totally agree. A breach will occur. Here's the question for most enterprises, though. What you just described was a very sophisticated customer. And we kind of call it the 1%, 99% problem. 1% of customers have certs, have SOCs, have response teams, have sophisticated approaches to actually mitigating these attacks. Fantastic. Awesome. What happens to the 99%? That's out there that don't have the ability to respond in those kinds of ways? So I think what we, as I said, once again, as an industry, what we've got to start doing is arming those people with tools that actually allow them to get back to the preventative posture that we used to have before. It won't be perfect. Nobody is perfect. What we're trying to do is get away from the point where we are right now, where the approaches to malware, they're kind of lucky to be 50% effective right now. Right? And we've got to get back to the point of actually being preventative. That's the major shift I'd talk about, that's all.